Okay, in this video we're going to look at composite shapes. We've worked on a whole lot of different perimeter and area problems involving rectangles, triangles and circles. So we're going to kind of put it all together, solve a few problems. Hopefully you'll be able to understand the strategies and maybe practice them yourself. So here's a wee shape, looks a bit like a pram or some kind of baby carriage, but we've got effectively a rectangle and a quarter circle. It says calculate the area and the perimeter. I'm not sure if which one is easier to do or more straightforward. So it doesn't matter which way round we're going to go, but quite often we have to work out a few dimensions first. Okay, it's a composite shape. So the first thing I would do would be to number the shapes so that I know what I'm talking about. I'll call the rectangle 1 and I'll call this circle part 2. The name we give to the actual fraction of the area of a circle is a sector. So that's a part of a circle. Well, let's have a work of perimeter first of all and see if we can piece it together. You notice that all the dimensions are there for the rectangle. We've got 5 on the outskirts there, 14. Now, it's an interesting point that we don't use the whole perimeter of the rectangle, because if you notice we've got 5 and then we've got 14 and we've got 5 and we've only got 8. We don't go all the way along, because then of course the shape goes this way, up and then around. So we're only using part of the area, part of the perimeter of the shape. So let's have a look. We've got 5 and 14. We know that's 5 and we've got 8. So that's all the straight edges there. Now these are radius lines. This sector here, that would be, this point here would be the center of the circle. So this is a radius and this is a radius, so they're both the same size, right? So if we know this is 18 here and we know the total length of the rectangle is 14, it stands to reason that this part here is 6, because 6 and 8 will make the same as 14, and with a rectangle the opposite sides are of equal length. So if that's 6, this is 6. That's an interesting fact that maybe you might have thought, well, I don't know that size. But remember that in a circle, all radius lines are exactly the same length. And what we do need to do is to work out the length of this arc. So that's the one calculation we've got for perimeter. So what I'm going to do, and what I'd like you to do, is when you're working them out, I'd like you to use the word perimeter or area as a little heading to say this is what we're working on just now. So we're going to work on the perimeter. I'm going to use a straight line because I don't like wiggly lines. So let's do a nice heading like that. And I've lost my R. So, okay, so we're working on the perimeter. So the key thing we've got to work out is the length of the arc. So we can say the length of the arc is, it's a fraction of the whole length of round the circle. Remember, the kind of virtual circle. If you were to draw the whole circle, it would have a radius of 6. And we know that the formula for the radius, for the circumference, is pi times the diameter. We've only got a quarter of the circle, so we might as well just say that the length of the arc is a quarter times pi d. So that's a quarter multiplied by 3.14 multiplied by the diameter. The radius is 6, so d equals 12 centimeters. So I'm going to use 12. And if I do that calculation, you notice that a quarter times 12 is 3. So I could get the answer just by doing 3.14 times 3. You don't always have to jump to using your calculator. 3 fours are 12, 3 ones are 3 plus 1 is 4, and 3 threes are 9. And the answer is just over 9, so it would be 9.42 centimeters. Now that's the length of the arc, 9.42 centimeters. So we can say that the perimeter is going to be at 9.42, and if I'm going around then from the top, 9.42 plus 5 plus 14 plus 5 plus 8 plus only one of the 6s. I'm only going to use the outer 6. Remember that inside 6 isn't part of the perimeter. So if I add up all of these, if I start from the other end, 6 and 8 is 14, 19, 19 and 14 is 33, add 5 is 38. So we've got 9.42 plus 38, and that gives me 47.42 centimetres. Technically, I should only really round to 3 significant figures. I said in the previous lesson that when you're using pi as 3.14, we can because that's only 3 digits, 3 significant figures, I can really only guarantee the accuracy to 3 significant figures. So I'm going to do that. Okay, but if you've got 47.42, it's not a big deal. Right, so that's the perimeter. A wee bit more involved than you might think. Let's have a look at area. So we'll do that down here, area. And okay. So what have we got? We've got area 1. Now what's that? It's a rectangle. So it's length multiplied by breadth, which is 14 multiplied by 5, and that gives us 70 square centimetres. That's not a problem. And area 2 is a fraction of the whole circle. So the circle formula is pi times r squared. So for this one here, because it's a quarter of the circle, I can again, just like I did for the length of the arc, I can just stick a quarter in the formula. It would be okay to work out area of the circle, the whole area numerically, then divide by 4, but there isn't really a whole circle, so I always prefer to actually recognise the fact that we only have a quarter of it. Okay, so we've got a quarter times 3.14, and the radius is 6, so we use 6 this time. 6 squared is 36, and a quarter of 36 is 9, so I'll get my answer just by doing 3.14 times 9. Okay, and that gives me 36. 9 ones are 9, plus 3 is 12. 9 threes are 27, plus 1 is 28. And 3 nines are 27, so I need an answer just over 27, so my decimal point will be 28.26. I would leave that unrounded just now. I might have to round it to significant figures, 28.26. So the total area, which I can write over here, total area equals A1 plus A2, which is 70, plus 28.26, which is 98.26. There's the fact that I'm going to round it then to 3 significant figures, 98.3 square centimetres to 3 significant figures. Okay, so problem solved. We've worked out the perimeter and we've worked out the area of the shape. Okay, there's some questions for you to try. I'm going to put another one up here. If you want to go away and practice from that, that's great. If you want to have a go at this one, a wee bit more involved, there's 3 shapes put together. You can pause it, try it yourself, and then go over your solutions with mine. You can leave it and come back to it if you get stuck with some of the questions that you're trying. So stay with me if you want, or you can go away and try it. So have a go at this. There's 3 shapes. I'm going to number them 1, 2 and 3. It doesn't really matter what. There's 1, 2 and there's 3. We'll work out the perimeter first. Let's have a look. We've got 3 straight lines. We've got 6 and we've got 10 and we've got 7.5, that sloping line. And then I've got this arc length. And again, that's the thing that I'm going to need to calculate. So we can say I'm going to work on the perimeter, and I would like you to follow my lead, which is, because we're working out 2 very separate ideas, I want you to be very clear what you're working on. So I am working on the perimeter at the moment. The one thing that I've got to work out is the length of the arc, and it's to do with pi times d, because that would be the whole circle, would be pi times the diameter. We've only got half of a circle, so the fraction I'm going to put in front of it this time is a half. A half times pi d is the length of our arc. So we've got a half times 3.14 multiplied by the diameter. So that's this line that goes all the way along here. Remember, in a semicircle, the diameter is the actual straight edge. Okay. So what is the diameter? What information do we have? Well, we've got right at the bottom here that's 13. Okay, so that's quite helpful. We've got 13 we can put in there, and then we can go on and work that out with the calculator this time. A half times 3.14 times 13 is 20.41. 20.41 centimetres. Again, I'll probably round it later on because that's 4 significant figures. So what have I got? I've nearly got the perimeter because I've got 4 lines to make up at the perimeter. I've got the 20.41, which is the curved part. So that's me got part of the perimeter. Okay, I've then got 6 and 10 and 7.5. So I can go plus 6 plus 10 plus 7.5. Add them all up. That's 20.41 plus 16 and 7 is 23.5. And I can add them together to get 43.91 centimetres. Well, there's 4 significant figures. That would be okay. It's not the end of the world if you leave it like that. I'm going to round down to 43.9 centimetres to 3 significant figures. Okay, for the perimeter. Let's have a look at the area. We've got 3 shapes put together here. We've got a rectangle, a triangle, and a part of a circle. So I've got area 1, and you have that conversation with yourself. What shape is it? Because it would be easy to use the wrong formula. So area 1 is a rectangle. I'm actually going to go right along and write out the correct formulas. Area 2 is a triangle. Half times base times height. And area 3 is a fraction of a circle. So that's to do with pi times r squared. And it's half a circle, so I'm going to put a half in there. It's really important when we're doing, you notice that we're using the 2 circle formulas. We're using pi times d up here for circumference, and we're using pi r squared. It's so easy to get these mixed up, or you end up using the same one. So you have to really keep your brain switched on and always thinking, what am I doing next? Okay, so that's me. I've actually written out all my formulas to make sure that I don't get mixed up. So in back to 1, I've got 10 times 6, which is 60 square centimetres. The triangle is a half multiplied by the base times the height. Well, the height is 6 because it's part of that rectangle. The base I don't know, but I do know that the bottom of that rectangle is 10 centimetres. And I know that the whole width of the shape is 13, which means that this must be 3 centimetres. So the base is 3 and the height is 6. 3 sixes are 18, and the half of 18 is 9 square centimetres. And lastly, I've got a half times pi, 3.14, times the square of the radius. Now be careful here. We used, and it's sometimes good even to take a note, we used the diameter up here as 13 centimetres. So that means the radius must be half that, which is 6.5 or 6.5 centimetres. Now 6.5 squared, I'm definitely going to use my calculator for that one. 6.5 squared times 3.14 times 0.5, it gives me 66.33, 66.33 and so on square centimetres. So we've got these 3 areas to add together. So the total area is A1 plus area 2 plus area 3, which is 60 plus 9 plus 66.33. So we've got 69 and 66 gives me 135.33. I'm going to round it to 3 significant figures. So the first digit I cut off is 3, tells me to round down. So I'm going to use 135 square centimetres for my area. Okay, so hopefully that makes sense. We can work out the perimeter and area of shapes which involve kind of composite shapes with triangles, rectangles, and parts of circles. Okay, I hope that's been helpful. Go off and enjoy doing some work on that.